Okay? So V1 is 10 volts. V1 is 10 volts. Whenever you know the node voltage, you do not have to do KCL. So because I know V1 is 10 volts, I don't do KCL at V1. Thank you for my 2026s, Donnie Don. Thank you for helping me achieve my goal. Hopefully it'll switch off of 2026 now onto something else, but we can only pray, right? And the supernode, the voltage on the left side of that supernode is V1. The voltage on the right side of that supernode is V3. I'm sorry, it's V2 on the left and V3 on the right. So if I did KVL around that supernode, you would see that negative V2 plus 5 plus V3 equals 0. Another way to state that is V2 minus V3 equals 5. V2 minus V3 equals 5. Believe it or not, TikTok Live Studio is trying to update to get rid of some bugs. It has still not opened up. Okay, so now thank you, Jacob Ryan. You're so sweet. God bless you too. Now we're going to do KCL at the supernode. Now we're going to do KCL at the supernode. Remember, a supernode is a floating voltage source. A floating voltage source means that the voltage source is not tied to ground. That's why this 10 volts is not a supernode, because it is tied to the reference node, which is 0 volts or ground. Okay? All right, so KCL at the supernode means I'm going to sum the currents into and out of the node. So what you're going to see, they're labeled for us. The current into the node is I1 plus I4. I1 plus I4. The current out of the node is I2 plus I3. KCL at the supernode is I1 plus I4, and the current out of the node is I2 plus I3. So now what we're going to do is I'm going to use Ohm's law to rewrite those currents in terms of voltages and resistances. I'm going to use Ohm's law to rewrite those currents in terms of voltages and resistance. So the first one you're going to have is I1 is 10 over 2. 10 minus V2 over 2. I4 is 10 minus V3 over 4. 10 minus V3 over 4. Okay? Then on the right side, the current out of the node is plus V3 over 6. Okay?